Hello LEGO engineers, welcome back for another awesome LEGO project today with Teacher Richard. Today we are going to be building our goal scoring robot. Alright, so you should get these blueprints out and have them handy just in case you get stuck on a step, or if I'm going a little too fast or a little too slow for you, you always have your blueprints to look at to remind you of exactly what to do for each step, okay? Now, our goal scoring robot engineers, we're going to see if we can make a robot that has real moving parts, okay, to be able to score a goal. All right, now I didn't say what sport my robot's playing because I wanted you to be able to decide what sport you wanted your robot to be good at, okay? Because I know that everyone likes to play different sports, all right? So some options that your robot can play: it can be a golfer, it can be a tennis player, it can be a baseball player, it can be a hockey player, all right? And I'm sure there are some other sports that I'm not thinking about, but anything where you have to hit a ball and score a goal or get it over a fence or into a hoop, all right, we can make our robot do that today with the right engineering pieces, okay? So we're gonna go ahead and get started on step number 1. All right, so we are going to start by taking 2 of our 7-hole red bricks, okay, and these are going to be the feet for our robot. All right, now remember last week when we built our drumming robot, okay, we discovered that it's best to use the biggest pieces on the bottom, all right, and then get smaller as we go up. So that's the same idea we're going to use for our goal scoring robot today, because our robot is going to have is going to be able to move, and when it moves, we don't want it to fall over. Okay, if you ever try to kick a soccer ball or swing a baseball bat when you're not balanced, all right, it's pretty easy to fall, and it's very hard to shoot the ball or the puck accurately. Okay, so we need to make sure that we have a sturdy foundation on our robot. All right, so I took my 2 7-hole bricks, and then I put my 3-hole bricks on top of those. Okay, and then going across, we're going to take our 7-hole thin rectangle, okay, and we're going to attach our 2 feet across using that brick right there. All right, so this is what yours should look like after step 1, okay? And then for step 2, we're going to start building the body of our robot. So to do that, we're going to take 3 of our thicker rectangle bricks, okay, and we're going to stack them up right on top of each other, 1, 2, 3, and then we're going to take those and we're going to put them on in the middle of that flat rectangle piece you just put down. Okay, so this is what yours should look like right now, and then we're going to add our 2 thin 3-hole rectangles that look like this. Okay, so we want 2 of those, and what we're going to do is we're going to put them so they're right next to each other on top of those rectangle bricks, and then we should have a little piece of each one that's sticking out, okay, on top of the rectangles. So this is what your robot should look like after step 2. Okay, so now we're going to flip the page and go on to step 3. Now step 3 is a big step, okay, engineers, it's kind of a multi-part step, so we're going to go slowly to make sure we get it all right, okay? Now we're going to start by taking 2 of our single hole bricks, all right, and we want to make sure that we use ones that have a circle in them as opposed to the plus sign. All right, so these are the 2 types of single hole 2-dot bricks that you have. We want to make sure we're using this one that has a circle on it, because the circle makes it so that we can spin our axles freely, okay? The plus sign we use when we want to be able to lock our axle into place. Okay, so if I spin my axle with this one, it spins the whole brick along with it, okay? And for our robot, we want to make sure that we can spin our axle nice and fast, because that's how we're going to get it to move, okay? So we're going to start by putting our 2 single hole bricks, all right? And we're using this kind of as a reinforcement because we're connecting this brick and this brick together, okay? So whenever you have 2 Lego bricks next to each other, we want to make sure that we have another brick on top to help them stay connected, okay? And I call those reinforcement bricks. All right, so you should be able to see right through yours, okay, if you built it right. And I like to call this the belly button of our robot, okay? And then once the belly button's on there, then we're gonna take our axle. This is the wrong one though. We're gonna take this axle, one of our shorter axles, not the longest one, okay? One of your shorter black axles. And we're gonna put it right through the belly button on our robot, okay? But don't worry, because this robot is strong and sturdy, just like you, okay? So they can handle it. And then on the axle, okay, we're gonna take our big 40 tooth gear, okay, and we're gonna connect it onto the axle, and then put that right through our robot's belly button, okay? So you'll see that my axle is going right through the middle of the gear, okay, through one of the plus signs. Now, we want to be able to spin our gear freely, okay, which is why we use the single hole brick that has a circle. However, we don't want it to slide this way. Okay, so you remember on our drumming robot what we used to help make sure it didn't slide? Okay, we used one of our lock pieces, okay, called a bushing or lock. All right, so we're gonna slide my lock piece onto the back end of the axle. So now we can still spin it. Okay, you want to make sure there's a little bit of space between the lock and the brick. You should be able to spin it pretty easily. All right, but now it won't slide back and forth. Okay, so that's exactly what we're looking for. And then we're going to take another one of our 7-hole bricks, and we're going to put one of the arms onto our robot. All right, so I'm going to put it on just like that, and then this side we still have space for our other arm. Okay. Now, before we go any further on to step 4, congratulations on completing a difficult step 3, engineers. Okay, but before we go on to step 4, I want to talk a little bit about this gear piece. Okay, because gears are a very important piece to lots of different cool engineering projects. Okay, and we're going to be using our gears this week to make our robot be able to score goals. Okay. But you can make gears do lots of different things. You can make lots of different projects using gears. Okay, so I want to show you why gears are so awesome. So I said that this was a 40 tooth gear. Okay, what I mean by that is that if you feel your gear, okay, and you look closely, you can see all these little grooves, okay, on the edge of my gear. So if we counted all of these, we would find out that it has 40 of them, okay? But if you don't want to count all the way around, okay, then there's a faster way to know exactly how many teeth are on this gear, okay? What we can do is we can see that there's a little notch, okay, that goes around the gears, all right? You see those 4 lines? So I like to think of it like a pizza, okay? And these are 4 slices that are in the pizza. All right, so instead of having to count all the way around, what we can do is we can count one of the slices, all right, and then we can count how many slices we have. All right, so I'm going to start right here, and we're going to say 1, 2, 3. Remember, you can do this along with me at home, okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so because we counted the tooth that matches up with this line, we don't count the tooth that matches up with this line. All right, so we end at 1 early. So we say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so there are 10 teeth in each pizza slice. All right, and we have 1, 2, 3, 4 pizza slices. Okay, so how many teeth do we have? 10, 20, 30, 40. Okay, and for those of you who know multiplication, we would take 10 and multiply it by 4. All right, so this gear has 40 teeth, okay? And that is how engineers, when they're talking to each other, that's how they know which gears they're talking about when a project has lots of different gears on it, okay? Because some projects can have 2 gears, 5 gears, 10 gears, hundreds of gears, even thousands of gears, all in one project, okay, engineers? But now here's the really cool thing about gears. You can have gears that are different sizes, okay? Obviously this one is bigger than this one, okay? You can have gears that are different sizes, but as long as the teeth, around the outside of the gear are the same size as each other, then when you spin one gear, you can make the other one spin along with it. Okay, so I can spin the medium gear and it will spin the big gear, or I can spin the big gear and it will spin the medium gear. Okay, now you actually have 3 different size gears in yours. The smallest one is the hard one to get out. Okay, now the small one, it's easy to count how many teeth we have on it, right? Okay, our very tiny gear. Now these engineers, these are easy to lose, okay? So if you drop one of the tiny gears, make sure you pick it up right away, okay? Because if you drop it and you're in the middle of a project, you say, oh, that's okay, I'll get it after the project's over, you might not remember exactly where it landed, okay? And we do not want to lose those small gears because we're going to use those in a lot of our different projects. Okay, so now I've connected 3 gears all together, engineers. We've got my medium gear, my big gear, and my small gear. All right, so what we have here is a gear system, okay? And what that means is that the gears are connected together, and anytime you spin one gear, it'll automatically spin all the other gears that are in our gear system, okay? So we can spin our medium, and it will spin the big and the small. We can spin our big, and it will spin the small and the medium, all right? And we can spin the small, and it will spin the big and the medium, okay? Now you may have noticed, engineers, that depending on which one you spin, it changes the speed, okay, for the other ones, all right? And that's because some gears are called the driver gears, and that means that's the gear that you're spinning with your finger, okay? Or if it was attached to a motor, it'd be the gear that's attached to the motor. And then the other gears are the driven gears, which means they're connected to the main gear that has the power source attached to it, all right? And remember, the power source for these gears are your hands, okay? So when I spin the big gear, you can see that it spins the medium gear pretty fast, and it spins the small gear really fast. Okay, so when the big gear is the driver gear, it makes the driven gears go fast. What happens when I make the small gear my driver gear? Are they spinning faster or slower than before? Okay, they're spinning slower. All right, engineers. So if you want your projects to move as fast as possible, okay, you want to have the largest gear be the driver gear, okay, and the smaller gears be the driven gears, okay? Because this gear is bigger, it takes longer for it to do a full rotation when I spin it, okay? And these gears will spin more per rotation, okay? But essentially what that means is that you want to spin the biggest gear that you have in your gear system and put your smaller gears next to it to make your project go as fast as possible, okay? Now you can imagine, right, if I had a Lego brick that was 100 dots long, 100 holes long, right, you could attach 20, 30, 40 gears on there and they would all be spinning together, right? We can make a huge gear system, okay? I also want you to think about that. Remember, the only thing that matters with the gear is not how big the gear is, but that the teeth on the gears are the same size as the teeth on other gears, right? So even though that tiny gear, okay, is way smaller than our 40-tooth gear, the teeth are the same size. So that means that you could have a gear that's as the size of your bedroom, okay, and another gear that's the size of your pinky finger, all right, if you put it in a circle, but as long as the teeth on the 2 gears are the same size, they would be able to spin together, okay? So we need to remember that because we're going to be doing that with other projects in the future, all right? Now, gears are easy to make a gear system with when they're all in a straight line like this, okay? But our goal scoring robot, all right, we need it to work a little bit differently, okay? Because what we want to do with our goal scoring robot is we want to make it so that when we spin our big 40-tooth gear, okay, that's attached to his belly button, all right, we want it to make a stick spin this way, okay? So we want it to spin in a different direction than the gear that we're attaching it to, all right? And I'm going to show you why that won't work using the gears that I was just showing as an example, okay? If I try to connect our large gear and this gear together like this, the teeth don't fit in with each other, okay? They're close, they're the same size still, okay? But they're not gonna be able to connect so that they spin freely, all right? So to make our robot be able to score goals the way we want it to, all right, we're gonna have to pull out this gear right here. And you'll notice it's the same size as this one, okay? But once you turn them this way, all right, you'll notice that the teeth on them are shaped differently, okay? The teeth on this gear are pointy at the top. The teeth on this gear are smooth on the top, all right? And that little minor difference, okay, will make it so that we can connect this gear sideways to our big gear, okay? So that's gonna lead us into step 5, all right, engineers, so that we can make the gear system on our robot work properly. Now, this gear right here, engineers, has a very special name since it's different than those other gears, and it is called a crown gear, okay? And the reason it's called a crown gear is because if you have it facing so the points are going up like that, and you imagine a bigger version of it, right? If you put it on your head, it would kind of look like a crown, wouldn't it? With all the points going around the outside edge. All right, so this is called a crown gear, and that is the official name of this gear. So if you were in a big fancy engineering meeting, all right, with big grown-up engineers, and you were trying to tell them which piece you can use to connect sideways to a big gear, you would say crown gear, and they would know exactly what you're talking about, okay? So it's a pretty cool name that's easy to remember because it's exactly what it looks like, all right? So for step 5, what we're gonna do is we're gonna take another one of our 7-hole red bricks, all right? I'm gonna put my crown gear on one of our red axles, and I'm gonna have it going through the middle hole, okay? And then I'm gonna make sure that the teeth are pointing away from the red brick, okay? The teeth should be pointing away from the red brick. And then once they're pointing away, I'm gonna put a lock on the other side like this. So once again, we can spin it freely like that, but we can't slide it back and forth, okay? And then, all right, we're going to take the 7-hole red brick and we're gonna connect it right onto the edge of our blue bricks like this. And you'll know it's connected properly because the teeth should be touching each other. And look at that, we have just made a gear system that goes sideways, engineers, okay? And if yours isn't working properly, make sure the teeth, the pointy end of the teeth are pointing away from the brick and towards the big gear, okay? If I flip this around, it would not work properly, okay? So if it's not working for you, make sure the crown gear is facing the right direction. Okay, so now we have our legs and feet, we have our stomach, we got our belly button, we have our arms, but we're gonna be twisting this part really fast, all right? And this arm's gonna start moving. So these pieces right now could fall off pretty easily, okay? So to make sure that they don't, we're gonna add another reinforcement piece. Okay, engineers, let me show you which piece we're gonna use. Another one of our thin 7-hole rectangles, all right? And this is going to be a reinforcement piece that goes across the belly button and both arms, all right? And so now, if I push down on one of these arms, it's not gonna break, okay? Because we wanna, whoop, the leg will, but the arm won't, okay? Because we wanna make sure that the arms are nice and stable before we start scoring goals, okay? So this is what yours should look like right now, engineers. All right. Now, we have this axle spinning, okay, but it can't exactly score goals yet, okay, because nothing's attached to this axle that's attached to the crown gear, okay? So we're gonna go to step number 7, all right? And step number 7 is when we're actually going to attach our stick, our bat, our tennis racket, our golf club, whatever you want to call it on your robot. We're going to attach that to our gear system, all right? So I'm pulling out my 11 hole brick. Yours might be gray, but mine is black, okay? And what I'm gonna do is I'm gonna take this, well, first I'll show you this. Watch what happens if we take this and we put it right onto the axle, all right? So now we think that when we spin it, right, it's gonna make this stick spin, this brick spin. But look what happens. I spin the axle, but the brick stays still, okay? And the reason for that is because we need to add another piece that will actually lock the axle into place and connect it to the brick. So for that, we're gonna use our crank or our lever piece, okay? Remember, we use this on our drumming robot to make it easier to turn, all right? So that's one thing that you can use it for, kind of like a handle. But here's the other thing you can use it for. What we're gonna do is I'm gonna take the pointy end of the crank and I'm gonna stick it into the 1, 2, 3, third hole down. All right, so this is what it should look like. And then now we can kind of swing it back and forth like this, right? It can pivot. So what I'm gonna do is I'm gonna swing it down so that now the pointy end is going into the third hole and this end with the plus sign matches up with the fifth hole. Okay, so if you just let it lay flat, it will line up right with the fifth hole down like that. And then what I'm gonna do is I'm gonna pick up my robot and I'm gonna slide the axle right through the fifth hole. Okay, so this is what yours should look like, engineers. And now when I spin it, now it's moving. That's what we're looking for, huh? Okay, and you can see this can go fast, engineers. You can do some damage with this. So make sure we're careful not to use this close to our little brothers or sisters or pets, all right, if they're not looking or they're not ready for it. Okay, so we are now on we just finished step 8, and your robot should be ready to score some goals, okay? However, we do have one problem. What are we missing? We're missing the head, right? So let's finish up the design part of our robot. And remember, engineers, this part of the project, okay, gives you some freedom, all right? This is what I wanted the face on my robot to look like. If you want yours to look different, you can absolutely do that, okay? Because I want your robot to look the way that you want it to, all right? The functioning part of our robot is done, right? It can perform the function or the job that we want it to, okay? So now what we're gonna do is we're gonna take my 2 circle pieces with 4 dots in 1 hole. I'm gonna connect those together, okay? Then I'm gonna take my 2 curved pieces like this. I should say 2 sloped pieces. So we have our 1 slope with 4 dots on it and the other slope with 2 dots on it. And then we can connect them together right like that, okay? I'm gonna put that on top of those 2 circle bricks, right like that. And then we're gonna take our eyeballs to make sure our robot can see exactly where they're shooting it, right? We'll put our eyeballs right on here. Now I think our robot is ready to play. Okay. Check that out, engineers. Okay, so what do you want your robot to hit? Okay, you have a couple options. You can hit a piece like this, if you would like. Okay, and when we hit it, all right, we want to make sure we can see where the stick goes. All right, so we're going to pull it back and then put the piece down, and then we can shoot it as hard as we want, okay? I'm not gonna shoot it as hard as I can because I don't want it to go off of the table, okay, while I'm filming. But you can hit yours, of course, as long as you want, okay? You can also use a brick like this to make a T, okay, if you wanted to try to get the piece that you're hitting up in the air. So let me show you what I'm talking about. If you've ever played golf, all right, or if you've kicked a football off a tee, okay, you know that if you put it high up on a tee like this, so I'm now hitting this brick right here and I'm using my yellow brick as a tee. If you put it high up in the air like this, okay, and you put it just right, all right, so that when you swing the brick's not going to hit the yellow tee. It's only going to hit the green brick. Okay, I'm going to hold it with one finger like this. This one I will hit hard because I'm going to see if I can get it in the air. All right, I want you to imagine that you have a football, a field goal post like this, right? Okay. I want you to imagine you have field goal posts like that. So you need to get the ball up into the air. Let's see if we can do it. Ready? 1, 2, 3. Oh. I think it went a little bit under. Let's try one more time. So what I'm going to try and do is I'm going to try and make it so that it's going to hit a little bit higher up on the brick, because that was too much fun. I got to try that again. So ready? We're going to say 1, 2, 3. They both went through. That was awesome. Okay, so we can try to kick a field goal with it. We can try to kick a regular goal if we want to make it like a soccer goal. Okay, we can try that as well. So for that, you can determine how high you want your soccer goal to be. All right, this is one way that you can make it. You can use 2 rectangles there. Right, we only have 1 rectangle left in your kit, I know. You might have more at home, but I only want to use the pieces that you have in the kit. So on the other end, we can use our 2 solo bricks like that, okay? And then we can see if we are able to score a goal. Now for the soccer goal, if you want, what you can do, if you don't want to lose any Lego bricks, engineers, this is what I recommend doing, okay? I recommend taking a piece of paper like this. I took a Post-it note and I crumpled it up. You can also take a tissue and crumple it up. And then now we can shoot it. All right, we can score. And if we lose it, that's okay, right? Of course, we'll try to pick it up. Also, if your brother or your sister or your mom or dad are watching, all right, and it accidentally hits them, a piece of paper is going to hurt a lot less than a Lego brick, okay? Because if you hit someone in the face with a Lego brick, it does really hurt. So make sure that you don't do it near anyone's face, okay? Now, a couple bonus challenges for you engineers, all right, is to see if you can make your robot be able to drive on wheels, okay? Now remember, with our drumming robot last week, all right, we were able to attach our wheels by using our connector peg like this that has grooves on one end and it's smooth on the other. And then we can connect it right into the middle of the wheel like that. And then we can go bada bing. We'll do it on the other side as well. Bada boom. Oops. Okay, because let's say you want your robot to be able to drive, right, quickly around the field or the tennis court or the golf course, whatever sport it is that they're playing. If you want your robot to be able to do that, then having wheels is definitely going to help them go faster, right? Now, I've attached those 2 wheels on that side. For the other side, engineers, okay, we're going to make sure that our wheel isn't in the way of the stick, okay? We want to make sure that it can roll, we want to make sure that it can roll without getting in the way of the stick that's swinging, okay? So to do that, you just want to make sure, you see how close that is to hitting it? Okay, so just make sure that your wheel's in the right spot on the very back hole so that it's not going to get in the way, it's not going to get in the way of the stick when it swings, okay? So just like that, our robot is ready to roll around the field. Okay, engineers? Now, I would love to see a picture of your goal scoring robot, okay, if you would like to send one to me. I would love to know what sport that it's playing. I hope that you were able to score a goal. I hope that you maybe could even figure out a way to turn it into a basketball player, perhaps, and maybe make a basketball shot. If you would like to see one way to do that, I would love to show you. I'm going to take this one off. The legs fall off when we move it, but that's okay. Part of being an engineer is knowing how to fix it, right? So we're going to put that back on right there. Put that back on right there. Now, I want to say a special shout out to an engineer in one of our live classes who figured out that you could use these bricks and kind of make it almost like a hand, all right? So what we're gonna do is we're gonna take our big long curved bricks like this. Now, it's gonna hit the ground if you swing it back this way, right? So, but that's okay, because what we wanna do is we can just have it right here. Okay, and now we can actually kind of use it. I'm gonna get another Post-it note that we can pretend is our ball, okay? And then what we can do is we can get it ready right about here, and we can put that crumpled up nice and good. All right, and we can see if we can actually get it to throw it. Oh, it threw it backwards because it's stuck in the hand, so whoops. So what we can do is we can try to, the wheels do make it less stable, engineers, which you've probably already figured out by how many times the wheels have fallen off. The wheels do make it less stable, similar to if you have ever ridden on roller skates before, right? Roller skates are fun, but you're definitely less stable. And then imagine if you were trying to play baseball on roller skates, right? That would be really unstable. So what I can do is I can spin it a little bit and then stop it right there, and then it will be able to throw it, okay? If you're building one of these with a friend, you can actually see if you can throw the ball to your friend's robot, okay? You can try to build a Lego basketball hoop and see if you can actually score a basket, okay? Or you can see just exactly how far you throw it using a measuring tape and see if your robot can throw it farther than it can hit it, like it did with our first model, okay? So engineers, I hope that you have fun with your goal scoring robot. All right, I'd love to see which cool modifications and customizations you add to it to make it even better than mine. Thank you for all your hard work today. I cannot wait to show you another great project next week. Have a great day, engineers.